Okay, what we have here is we're going to be talking about verifying trigonometric expressions, and there's some things that you have to know in order to identify trigonometric expressions, and that first starts with knowing the fundamental trig identities. Okay, the fundamental trig identities, because we're going to use these a lot to verify, and they're going to help us simplify different trigonometric expressions using algebra and whatnot. Now, the first fundamental trig identity is the sine, or I should say the cosine squared. All right, cosine squared of an angle, all right, plus the sine squared of an angle, that equals 1. That is the mother of all trig identities, and that comes from, all right, the unit circle. X squared plus y squared equals 1 squared. X squared plus y squared equals 1. X, we know, is equal to the unit circle is a cosine of an angle, and y equals a sine of an angle, and therefore with a little substitution, that's Cajun for substitution, you can get this, what is known as the fundamental trig identity. Now, from this fundamental trig identity, we can identify everything squared. So for example, the sine squared of theta, and you want to write these down and memorize them, sine squared of theta is actually going to equal 1 minus, if we subtract that other side, cosine squared of theta. If we want to know what cosine squared of theta is, we're going to take and we're going to subtract sine to the other side of this fundamental trig identity. Now we have sine, cosine. How do we figure out what tangent squared is, secant squared is, all right, and all the other ones that we know. All right, so let's say we have secant squared of theta, and then we have cosecant squared of theta, and how about cotangent squared of theta? Do those have some identities as well? Well, yes, they do. We find those by actually taking this fundamental trig identity and rewriting it. And like, for example, let's say we took and we divided everything by the cosine squared of theta. Well, if we divide through the fundamental trig identity with the cosine squared of theta, all right, and we just think about this, and I'm going to say that equals 1. So we just distribute that through. What we'll have is cosine squared of theta over cosine squared of theta, which happens to be 1. We'll have sine squared of theta over cosine squared of theta, which we know is tangent squared of theta. And then we'll have 1 over cosine squared of theta, because we just read that all the way through, and that's going to equal secant squared of theta. So we already found out that secant squared of theta equals 1 plus tangent squared of theta. If I want to know what tangent is, I can subtract the 1 to the other side, and I know that's going to equal secant squared of theta minus 1. Cool, huh? Well, if I want to go a step farther, what we can do is take the same fundamental trig identity and take it and multiply by 1 over sine squared of theta. All right, that same fundamental trig identity, I'm going to take it and multiply by 1 over sine squared of theta. Well, you might be thinking, well, that's cosecant. You're right. Okay, and what we have then here is cosine squared of theta over sine squared of theta. What happens to equal cotangent squared of theta. We get sine squared of theta over sine squared of theta, what is going to equal 1. And then we get 1 over sine squared of theta. Oops, I forgot that. We don't just do that. We're just going to have 1 right there. All right, got a little ahead of myself. All right, equals 1 over sine squared of theta. Okay. And that's going to equal cosecant squared of theta. And bada bing, bada boom, we just identified all of the fundamental trig identities. So this is going to equal cotangent squared of theta, all right, plus 1. And if I want to figure out what cotangent is, well, cotangent is going to equal cosecant squared of theta minus 1. One of the cool things that you notice is that I always say the C's stick together. Cosecant squared and cotangent squared kind of stick together like peas and carrots. All right, and tangent and secant stick together with peas and carrots. as well. But this is where they come from, all from this basic fundamental trig identity, sine squared theta plus cosine squared theta equals 1. Okay. I'm going to stop here, and if you want to check out my next video, we're going to go through and how to use these to find equivalent expressions. But take these, memorize them, know them. It's going to serve you well, my friends.